Hello, Algebra 1. This is the video key for section 7.3 on greatest common factor. And I've kind of written just a couple of steps that really is all it takes to find that greatest common factor. And we have our expressions. First, we're going to find the greatest common factor of our coefficients. We're going to pull that out. And then we're going to find the greatest common factor of our variable terms, and we pull that out of there. So it's really just those couple of things we need to look at, but let's do a few examples and get started with question number 1. So number 1 is 40n plus 72n squared. That's the expression. We need to factor out the greatest common factor. Well, step number 1, we're going to look at our coefficients first. We're going to find the greatest common factor between 40 and 72. So I'll take this first step. We'll go through it the long way, but after this, we'll just kind of speed through the common factor part here. But on this one, we'll start with 1 and 40. Okay, if you remember back to our factoring numbers lesson, we put the smallest term over here, largest on the right, and we just find the common factors in the middle. So we'll start off with 1 because 1 times 40 is 40. Next is 2. Does 2 go into 40? Yeah, 2 is going to go into any even number. How many times does 2 go into 40? It goes 20 times. 2 times 20 is 40. Does 3 go into 40? It does not. What's our test? Well, we add the two digits together. If that's divisible by 3, then the larger number is divisible by 3. 4 plus 0 is 4. 4 is not divisible by 3, so we'll move on. Does 4 go into 40? Yes, it does. 4 goes into it 10 times. 4 times 10 is 40. Does 5 go into 40? Yes. What's our test on that? If it ends in 0 or 5, that means that number is divisible by 5. How many times does 5 go into 40? It goes 8. So you can see we've closed this gap really quick. So let's just look at the two numbers in between now. Does 6 go into 40? It does not. Does 7 go into 40? It does not. So here are all our factors of the number 40. Next, we're going to look at the number 72. So we'll start off with 1 on our left, 72 over there on our right, and we're just going to close the gap, finding factors in between. So does 2 go into 72? Sure. Remember, any number that's even, 2 goes into it. So how many times does 2 go into 72? 36. Next number is 3. Does 3 go into 72? It does. What was our test? Remember adding these digits together. 7 plus 2 is 9. Is 9 divisible by 3? It sure is. So how many times does 3 go into 72? 24 times. 3 times 24 is 72. How about 4? Does 4 go into 72? It does. Goes in 16 times. No, 18 times. I'm sorry. 18. 4 goes in 18 times. 4 times 18 is 72. Does 5 go into 72? No, remember it has to end in 0 or 5. Does 6 go into 72? Yes, 6 goes in 12 times. Does 7 go into 72? It does not. But does 8? Yes, it does, and it goes in 9 times. So there's our list of factors for 72. So when we're looking for the greatest common factor, we're going to find the largest number on this list that is also on this list. And it looks like, looking at both of them here, it's going to be the number 8. So we know that the greatest common factor of our two coefficients is 8. I'll erase our factor list here. All right. Second step, we're going to find the greatest common factor of the variable terms. We have n and n squared. I put a little note on here that what we pull out is we pull out the variable term with the smallest exponent. Now, first of all, the variable has to be present in both terms. Since we do have an n term here and an n term here, we can find a greatest common factor, and that greatest common factor is going to be the n term with the smallest exponent. And that would be this one right here, which is just n to the first. And we just write that as n. So this is our greatest common factor, and this is what we're going to pull out of the term here. So we're going to first divide 8n into 40n. We'll do the coefficients first. How many times does 8 go into 40? 5 times. And n divided by n, well, it's just 1. They cancel out. Next, we're going to divide 8 into 72. How many times does 8 go into 72? It goes 9 times. And if I take an n out of n squared, what am I left with? Just n. N times n equals n squared. So this is our answer for number 1. 8n times 5 plus 9n. Number 2 is 6x squared y cubed plus 6x y to the 5th. So we define the greatest common factor and pull that out of this expression. First, the coefficients. Well, obviously, the greatest common factor of 6 and 6 is going to be 6. Now we need to find the greatest common factor of our variable terms. We'll start with x. We make sure it's present in both terms. It is. We have an x squared here and an x here. And when we're looking for that greatest common factor of the variable terms, we're looking for the one with the smallest exponent. So that would be this one here with just the x. Next up is y cubed and y to the 5th. First we make, the y is present in both terms. But now to find that greatest common factor, we're pulling out the one with the smallest exponent. That would be this one right here, y to the 3rd. So our greatest common factor is going to be 6x y to the 3rd. So now we're going to divide our greatest common factor in our expression up here. We'll start with the coefficients. 6 into 6, that goes one time. How about x into x squared? If I pull an x out of x squared, that leaves me with x. If I pull a y cubed out of y cubed, well, they cancel each other out. So now I'm going to add again. I'll have 6 divided by 6 is 1 again. X into x, they just cancel out. And if I take y cubed out of y to the 5th, that leaves me with y squared. Remember, if I have 1 as a coefficient, I don't write it. So there's my answer there, 6x y cubed times x plus y squared. There's our answer to number 2. Hey, here's number 3, 12x to the 4th minus 4x cubed plus 16x squared. We want to find the greatest common factor. We're going to start looking at the coefficients, 12, 4, and 16. So let's look at our factors on each one. Factors of 12 are 1, 2, 3, 4, 6, and 12. Factors on 4 are 1, 2, and 4. And our factors on 16 are 1, 2, 4, 8, and 16. Okay. And we're not going to slow down to do all the factoring numbers, but if you need to work on this, go back and watch the factoring numbers lesson again, and you should be able to get some practice on factoring numbers here. But for now, we're looking at the greatest common factors. That's the largest number that is on all 3 lists, and it looks like that's going to be the number 4. So we know for our greatest common factor, the coefficient will be 4. Now we look to our variables, and we have a variable term of x. Is it present in all 3 terms? Yep, we got x to the 4th, x cubed, and x squared. And when we're talking about the greatest common factor with variable terms, we're looking for the smallest exponent, which would be that one right there, x squared. So we know our greatest common factor is going to be 4x squared. And that's what we're going to pull out of this expression right here. So we'll set up our parentheses. We're going to divide 4x squared into 12x. Well, 12 divided by 4 is 3. When I take x squared out of x to the 4th, that leaves me with x squared. 4 divided by 4 here, that's going to be 1. And remember, we've got to watch our signs here. This is subtraction, so it's going to be subtraction down here. So 4 divided by 4 is 1. When I take an x squared out of x cubed, that leaves me with x. And then I'm going to divide 4x squared into x squared. 16 divided by 4 is 4. And when I take x squared into x squared, that just cancels out. So we have a 1 as a coefficient, so we don't write that. And this would be our answer here. 4x squared times 3x squared minus x plus 4. Okay, number 4. 5n to the 5th minus 5n squared plus 5n. So first thing I'm going to do is find the greatest common factor of the coefficients. Our coefficients are 5, 5, and 5. That was pretty easy. Our greatest common factor will be 5. Now we're going to find the greatest common factor of our variable terms. The only variable present in all 3 terms is n. And we're looking for the one with the smallest exponent out of n to the 5th, n to the squared, and n to the 1st, and that would be just n. So we're going to be pulling a greatest common factor of 5n out of our expression here. 5 divided by 5, that's just 1. When I take an n out of n to the 5th, that leaves me with n to the 4th. 5 into 5 here, that's also 1, but let's watch our sign. With subtraction here, so it remains subtraction here. If I pull an n out of n squared, that's just going to leave me with a single n. And finally, 5n divided by 5n, is 1. Okay. So here's my answer. So if I have 1 as a coefficient, I can get rid of that. I'm left with, there's my answer, 5n times n to the 4th minus n plus 1. Number 5 is 20m to the 3rd power minus 20m minus 16m squared. Step 1, we're going to find the greatest common factor of our coefficients. Our coefficients are 20, another 20, and 16. Our factors of 20 are 1, 2, 4, 5, 10, and 20. Our factors of 16 are 1, 2, 4, 8, and 16. And I'm looking for the largest number that appears on both lists, and that would be the number 4. So I know the coefficient of our greatest common factor is going to be 4. Now I look to my variable terms, and I have an m present in all 3 terms. I have n cubed, m, and m squared. And I'm looking for the one with the smallest exponent, and that would be this one right here where I have m to the 1st. So my greatest common factor is 4m. I'm going to pull that out of this expression here. I'll do the number first. 20 divided by 4 is 5. And when I take an m out of m third, I am left with m to the 2nd. 4 into 20, still 5. Watch my sign. If it was subtraction up here, it's subtraction down here. And m divided by n, well, that's just 1. They cancel out. And I'll do 4 into 4. Or, sorry, 4 into 16 is 4. And now when I take m out of m squared, I am left with a single m. So there's my answer to number 5, which is 4m times 4m to the 2nd minus 5 minus 4m. Here's number 6, 4 into the 7th plus 2 into the 4th minus 2 into the 3rd. So we need to find the greatest common factor of our coefficients. Our coefficients are 4 and 2. Our factors of 4 are 1, 2, and 4. And our factors of 2 are just 1 and 2. What's the largest number appearing on both lists? That would be 2. So the coefficient of our greatest common factor will be 2. Now we need to find the greatest common factor of our variable terms. It has to be a variable present in all 3. We have n to the 7th here, we have n to the 4th here, and n to the 3rd here. So we have n in all 3 terms, and we pull out the one with the smallest exponent, which is here, n to the 3rd. So our greatest common factor is 2 n to the 3rd. Now we're going to divide that into each one of these 3 terms. So we'll start with the first term, the coefficient. 4 divided by 2 is 2. And when I take n to the 3rd out of n to the 7th, I am left with n to the 4th. Secondly, we have 2 divided by 2, that's 1. And when I take n to the 3rd out of n to the 4th, I'm left with just n. And finally, 2 divided by 2, that is just 1. And when I take n to the 3rd out of n to the 3rd, well, they cancel out. So if I have a coefficient of 1 with a variable, I don't need that 1 there. Let me bring this parentheses in closer. There's my answer. 2n to the 3rd power plus 2n to the 4th plus n minus 1. The answer here. This is one of those questions that photomath takes a step further. So I do write some questions like this every once in a while that photomath answers differently than what I have here. So these are one of these questions kind of on every assignment or so that we wanted these that I'll know if you guys are using that tool. So let's learn the steps here and make sure we're working them out correctly. Number 7, 12x to the 4th plus 16x squared plus 20x. First step to find our greatest common factor of this expression is to find the greatest common factor of the coefficients. Our coefficients are 12, 16, and 20. Let's look at the factors of 12. We have 1, 2, 3, 4, 6, and 12. Our factors of 16 are 1, 2, 4, 8, and 16. And our factors of 20 are 1, 2, 4, 5, 10, and 20. Now we're looking for the greatest common factor, so the largest number that appears on all 3 lists. And it looks like that's going to be our number 4. So we know the coefficient of our greatest common factor is going to be 4. Now we need to find the greatest common factor of our variable terms. So let's look at all three terms. We have a variable present in each one, x, x, and x. We sure do. And what we're looking for is the variable term with the smallest exponent, x to the 4th, x squared. That's just x to the 1 there. That's our smallest exponent. So we know our greatest common factor is going to be 4x. So we're going to divide that out of here. So when I do 12 divided by 4, I get 3. When I take x out of x to the 4th, I'm left with x to the 3rd. When I divide 16 by 4, that's 4. When I take an x out of x squared, that is just x. Now I do 20 divided by 4, that is 5. X divided by x, well, they'll cancel out. And there's my answer there for number 7, 4x times 3x cubed plus 4x plus 5. Here's number 8, 4x to the 5th power times y minus 2x squared y cubed minus 8xy squared. We need to find the greatest common factor of this expression. We'll start by looking at the coefficient. That's step 1. So our coefficients are 4, 2, and 8. We'll look at the factors of each term. Factors of 4 are 1, 2, and 4. Factors of 2 are just 1 and 2. Our factors of 8 are 1, 2, 4, and 8. So we're looking for the largest number that appears on all three lists, and that would be our number 2 there. So we know the coefficient of our GCF is going to be 2. Now let's look at the variables here. We have x's and y's, so we have to make sure they're present in all three terms. Our x's in all three terms, we have x here, x here, x here. So yes, we need to find the smallest one. That's x to the 5th, x to the 2nd, this is x to the 1st. So we know we're going to pull out the x. Now we have y here, and y here. So we can find the greatest common factor with y. It's y to the 1st, y to the 3rd, y squared. So it's just going to be y to the 1st. So our greatest common factor is 2xy. We're going to divide that into each term. So 4 divided by 2 is 2. When I take an x out of x to the 5th, I'm left with x to the 4th. Y out of y, they just cancel each other out. So on to the next term. 2 divided by 2 is 1. When I take an x out of x squared, I'm left with x. When I take a y out of y cubed, I'm left with y squared. I'm going to do 8 divided by 2 is 4. If I take an x out of x, they cancel each other out. And a y out of y to the 2nd leaves me with just y to the 1st. And if I have a coefficient of 1, I don't write it. So here's my answer to that question, 2xy times 2x to the 4th minus xy squared minus 4y. Number 9 is 54v to the 4th u to the 9th minus 30v to the 4th u to the 3rd. So we need to find the greatest common factor of that expression. So we're going to start by looking at our coefficients. Our coefficients are 54 and 30. So our factors of 54 are 1, 2, 3, 6, 9, 18, 27, and 54. Okay, those are going to be my factors of 54. Now let's look at 30, where I have 1, 2, 3, 5, and 6, 10, 15, and 30. We're going to be looking for the largest number that appears on both of those lists. It looks like it's going to be right here with 6. So we know the coefficient of our greatest common factor is going to be 6. So we erase our list here. And now I need to look at the variable term. So I need to make sure that if I have a v variable here that it's present in the other term, it is. I have a u variable here and it's present in the other term as well, so we can find v and u. So we're looking for the smallest exponent. Well, we got v to the 4th and v to the 4th, so we can pull those out of both. So v to the 4th would be the common factor there. U to the 9th, u to the 3rd. Remember, we're pulling out the one with the smallest exponent. That's u to the 3rd. So our greatest common factor out of this expression is going to be 6 v to the 4th, u to the 3rd. So when we divide 54 into 6, that goes 9 times. And v to the fourth, they're just going to cancel out. When I take u to the third out of u to the ninth, that leaves me with u to the sixth. 30 divided by 6 is 5. V to the fourth, they're going to cancel out. U to the third out of u to the third, that's going to cancel out. So there's my answer right there. 6v to the fourth, u to the third, times 9u to the sixth minus 5. Here's our final problem of the homework exercise, and that is number 10, which is 20m cubed n plus 10mn. So we need to find the greatest common factor of this expression. We'll start with the coefficients. We have 20 and 10. Our factors of 20 are 1, 2, 4, 5, 10, and 20. And our factors of 10 are 1, 2, 5, and 10. And what we're looking for is the largest number that appears on both lists. And that's going to be 10. So we know the coefficient of our greatest common factor is going to be 10. Now let's work on the variable part. And we look at variables that are present in both terms. We have m here, and m here, n here, and n here. So we are going to pull out the variables with the smallest exponent. Let's look at m first, m to the third and m to the first. So we're just going to pull out that m. Then we have n here and n here. So that's our common factor. We have n present in both of them. So our greatest common factor is 10mn. We're going to divide that into each one of these terms. So 20 divided by 10 is 2. When I take an m out of m cubed, I'm left with m to the second. And n into n, they're just going to cancel out. 10 divided by 10 is 1. I have m into m, that cancels out. N into n, that cancels out. So our answer will be 10mn times 2m squared plus 1. So hopefully going through these exercises helped you in understanding greatest common factor. If not, please email me. We'll work through some more. Or if you're stuck on one of these problems, we will work through that together.